Hello guys and welcome to my channel. And actually this is the first video I ever made. I'm making this is the first video I'm making for YouTube, and it's actually my first video ever, so I'm welcoming myself. In this video in this channel I'm going to develop live projects that I always wanted to build, and we will start with this project today. This is my first game that I'm trying to make in OpenGL. I don't really have any experience working with OpenGL, but I do have in C. I've actually coded in C till it's been 3 years now, so I have some kind of experience with C programming. I wanted to apply that to graphic programming too. So in this series we are going to develop my first game. Actually, not I wanted to say our first game, but it's actually my first game. And sorry for my accent. I'm Cameroonian. I'm in Cameroon right now. Right now, and I'm in Yaoundé, and I do speak French, but I also speak English. So I'm going to produce my videos in English language. So for those of you who understands English, please, if I make some mistakes, don't judge me. Just leave in the comment section below what you think will be better, what could improve it, my pronunciation, my vocabulary and grammar and stuff like that. So let's stop talking and go right to the point. So this is a boilerplate code that I've put in place. It's just like we are just initializing SDL. Creating the window and the renderer, looping until we close the application. Here we are just listening for some events, like we create or we press the escape key on the keyboard, and here we are just rendering. So on here we are just rendering. Oh god, this okay, and we close. That's all there is to do. And like I'm going to run the application now, and just for you to say, okay, this is what we have. This is a window and it is resizable, but this is done in OpenGL. Oh my god, look at this. Like when I shrink like this, but when I look at this dark actually, but whatever, we are going to do it in OpenGL anyway. So we will get rid of a lot of SDL3 codes. What I want to do is to turn this into an OpenGL project. So we are going to follow the tutorial on this website. The link will be in the description. Is the tutorial on Antoj whatever. So I'm going to leave the comments in the link in the comment below, so go and check it out. This is the book that we are going to follow, and as I said, is Anton's OpenGL 4 tutorials. I wanted to follow this OpenGL. Let's quickly look at this. Oh my god, the connection. Actually, I'm offline right now. What looks like I'm offline, guys. Sorry for the connection. We are in Cameroon, so the Cameroon connection is a hell ton of headache. So I think I'm just going to stick with this one. Jeez, my Wi-Fi is, sorry guys. Okay, as I said, I wanted to follow this tutorial, but to follow this tutorial I think is on this website, something like this. Nope, maybe here, I think. Like, but the thing is that it's in OpenGL 3.3, so it's pretty old, and I didn't want to follow that, so we are going to follow this instead. We are going to follow this, and if we click on the halo triangle, oh my god, okay, it says halo triangle OpenGL 4 up and running. So the idea of the article is to give a brief overview of all the key parts of OpenGL program without looking at each part in detail. If you have used any graphics API, actually I don't before, you want an at a glance look at the differences, then this article is for you. If you have never done graphic programming as like me before, then this is also a nice way of getting started with something that works and can be modified. The following article will step back and explain each part in details. So what still recording, sorry for that. What we want to do is like to turn this SDL. I have a little bit of experience working with SDL, so that's how I was able to put this code in place, but I don't need to open it. So here, this is just I just want the hello world. This is a simple hello world. I've already set up. Hook up OpenGL function with glad. Actually, I don't want glad because this tutorial uses GLFW, and in order to use GLFW, GLFW loads the OpenGL from your machine, but GLFW actually use load OpenGL 1.2. So in order to use new features of OpenGL, you also have to get glad. So you also have to get this guy glad, and I know how to set it up. Maybe I will do a tutorial on that to show you how to set that up, but today what I wanted to use is actually SDL, because in SDL we can, and this is actually the major use of SDL3, because I made some research previously and I found out this is actually the most use case of OpenGL is to use OpenGL to initialize OpenGL or Vulkan or DirectX for Windows. So we will use SDL here to initialize OpenGL, and you can see that I've put this SDL flag here. So this is how I'm able to use OpenGL. And this is how you should include it. Yeah, this is we have our own project setup. You can see in this src folder I have the include folder, which holds my definition. Here is the util file in which I've defined an error function, actually a generic error function. This is the util file, utils.a files, and we're working with a CMake file. I have my SDL in this path. So if you guys, because you can find this code on GitHub, I will put the link below. Continue if you have a Windows machine, because I do have Windows and Linux. Today I'm recording on Windows, but tomorrow or maybe someday actually I will be recording on Linux. So if it's on Linux, this is work fine. Just have to install SDL on Linux. But if it doesn't, like if you are on Windows, you have to. I made some researches and I found this approach, for me at least, much more acceptable. The only thing is this path. So maybe I will make this dynamic as I'm going, because I'm pretty sure that you guys don't have this. So, but we have this CMake, we load these files, we define the include directory. Actually, I can, include include directory to be this, so that we in the include directory we don't do src that include that util src slash include slash util.h, but we only do include util.h. Whew, that's a lot. Okay, let's go to this. We can see here that we initialize glf. glf has nothing to do with OpenGL. glf is used to give us a window so that OpenGL can render on that window. But for us, we are using SDL to give us a window to give us also give us a window, and we are able to render it. So what we are going to do is look at this code. Okay, first what I want to do is that we are going to refactor everything here. So we are actually going to delete everything, and here we are going to do what we can do. We can do struct. What we can do is call it app, and in here we want to define the window, the renderer, this running. This is what I want to do. This is what I want to do, and in here what I want to do is if SDL init video. If it doesn't do, we are going to use this function failed initialize SDL3 error SDL. Oh god, Windows, like it can't follow as I'm typing. What is this shit? Anyway, sorry guys. Exit failure. Okay, well, like since I do this, I want to go create exit success. Okay, like this is what I have so far. So what I want to do is I want to initialize this. I call it application. I want to initialize it, and maybe I want to do, actually I think I'm able to do this. I'm able to do if it's running true. Actually I'm using, okay, it's running true, and window is new render. Wait, what? I don't have Windows. Window, God. Ah, okay. Okay, this is it, and I want to do if. Okay, like I have an application. I have my application now. I have my application, and what I want to do, let's come up here. Let's come up here. Okay, let's leave it. Okay, we have initializers there. We have to set this. We have to, yeah, glf window int. We have to set the context, glf context version major 4 major 1. Actually, I don't know if we have loaded the OpenGL. Okay, yeah, this is it. We have loaded it. So we are going here. What we can do is look at this. Let's see. Yes, it's still recording. Okay, glf context major 4. And also guys, look for the lights. Like it's dark in here and my camera is not good, so I wanted to put full light, but it's not working quite good. Let me show you. Like actually it's not good. I wanted to turn it to red, but it's also not good. To green, not so white. To white, no. So this fading thing. So I think I'm going to leave it like this. Okay. And here the major. Okay, what function do we use to in SDL to window int? Okay, we can go and check it out. Like we can do SDL window int GL swap window. Okay, let's search how we can set the what the major and minor version of OpenGL to for that one using SDL3. Look at this. Actually, this is my use of AI. Like I go on Google, I made some research and I get this quick response. Here is SDLGL set attributes, the SDLGL context major. You can see this GLF window int. Here is SDLGL set attribute. Yeah, because in the attribute GLF int, maybe that's because I don't know the English, but anyways, we have SDLGLF set attribute SDLGLS context major version 2.4. SDLGLS context minor version. Also this profile is OpenGL forward pack. I'm pretty sure I can do set attribute SDLGL. What is this called? Is forward compact. Yeah, context forward compatible to is what? GL3. Okay, it's SDLGL. There is no true GL. GL true. Maybe I have to. Like, let's go. Okay, this is the value. How am I supposed to? Okay. Let's find it. Like if I put true. Like let's find the OpenGL profile. Okay. So set attribute GL context profile core. Okay, and is open your profile call here. Context profile call actually. But this line I'm not quite sure. What is it? What is the equivalent of the in SDL? Oh, not 4, 3. Anyway, it's AI. It's actually, yes, it's just true, false, you know. Okay, it's just true, false. So it means that this part is done. This part is done. Then here, create a window on the operating system, then tied it to the OpenGL context. Okay. Create a window. It's easy as doing application window SDL window. The title of the window is Hello World. The dimension is window width, window heights, and the flag SDL window OpenGL SDL window size. Okay. And here I'm going to do with actually, since they don't change, I'm going to make them, and here if application window is still null, we report fail to create a SDL3 window. SDL get error. Then as we return here, we are not going to return like this. We are going to SDL, and here you are going to just quit. You have created a window. Create a window. Create a window. Then we make the window the current context. The current context. So what we can do is GL make context current. GL context get make it takes the SDL window. What is also take the context, set up a OpenGL context for rendering into the window. OpenGL context associated with that is how to set the window as the current context window in OpenGL using SDL3. Context, the call function, but what is the context? Let's just give it the example. We get the current context. Let's say create a context. We create a context and we get the current context. Okay, so here is what is SDL context, gel current context, SDL gel. Create context. And we create a context and we made the current context. So if the gel current context is known, fail to create the current context. SDL get error. Then SDL destroy window application and we have created a current context. The current context, and we want to set SGL set no make current context application Windows current context. Then what does this function do? It says set up OpenGL context for rendering. The content must have been created with compatible window. This function should be called, this function is available, but is raised true unsuccessful. For more information, actually, so it means we have to call this fail to get the current context. Then I will do SDL destroy window. Can it be destroyed? Can it be destroyed? Can it be destroyed? This function should be called on the main thread. This function may, on failure, the window associated to the context. Okay, window with new, will be created with the current state set through create the OpenGL content for OpenGL window and make it current. The OpenGL content will be created with the current state set through SDL set. Must be created with the OpenGL flag or context will fail. Windows user new to OpenGL should note that for history reason, GL function added after OpenGL 1.1 are not available by default. Those functions maybe this is not of our concerns. I lost the Wi-Fi. Sorry guys. Now we are going to destroy context actually. We SDL destroy context and it takes the GLF current context. SDL destroy context, their current context, destroy Windows application window. Actually, this I really don't want this. So something like I have the current context. Good. Now, glad we are not using glad. SDL already handled this for us. So we loaded OpenGL. We get the version, glad version major, version minor. What is the load OpenGL? The version of the renderer get string. Try to call some OpenGL function and print some more version info. So what we do, this is already much, really much, but this is C. So we print, there we get the name of the renderer. Actually use the renderer, this is the renderer. Yeah, OpenGL is also a renderer. Yeah, version support is here renderer. Okay, so here we going to do printf. What is it? Renderer. GL is get string. Get renderer name. Renderer name. Okay, let's go to this file. OpenGL. Renderer. Okay, this is, so we look for OpenGL. Get the name of the software. CPU renderer. (2D) renderer. Use this function to get the name of the 2D renderer. Is SDL get renderer driver. So render driver. The index of the render driver, the value range from 0 to get numbers of render driver. It is safe to call this function from any threads. From any threads. So my Wi-Fi is bad, guys. Like, I'm actually getting the name of the first renderer. I don't know if there is a second one or a third one. I don't know. So the version, OpenGL version support. know if it's this, so let's go to here again. Renderer. OpenGL version. Version. OpenGL. OpenGL. Okay, since my connection is back, how to get the OpenGL version using SDL. To get SDL, you can query the query and the content via the SDL get attribute API and read the native OpenGL driver using this SDL built-in. So the minor, so the version get attribute SDL. So what we can actually do this is to define major and minor, and what we can do is get attribute SDL context major version, SDL context major version, major minor version. Major minor. Let's look at this first. Get attribute. This context. Major version profile lead. Oh. Yeah, the name now. The built-in video driver. Get the name of the currently available video driver. Name OpenGL support. Get an OpenGL function by name. The name of the extension to check. Name of the built-in driver. The name of the built-in get video driver. Get video driver. Get renderer. Let's try to run this and see. Oh, failed to get the current context. I get an error. Failed to get the current. If it's false, because okay, this is it. Render direct 3D one. The video drivers. In the compiled OpenGL version supported here. So this is, I properly get the OpenGL. Got OpenGL version. Yeah. And Windows. No. What is the equivalent of this? Share renderer. Using SDL3. Let's check if this is what we did. Get SDL get render name. We don't have a renderer. If you are like yeah, actually, OpenGL, because this is native function now. This is native function. This is native function. I can include SDL3. OpenGL. And in here, I can do this. Let's wait. Printf renderer. GL get string. GL render. So, well, this is a byte and sign char. So this is GLF get string. GLF version. Then let's run it. Link. Render. You see, this is. Yeah. The renderer, you see, now we get with actually, but look at this. Look at this. DirectX, Direct 3D 11 Windows. Get the video driver Windows, the Intel RUH. This is the real. Yeah. So I can just go here and remove this for. Then I do this. Then let's say the version build, the version for that 1.0. So guys, this is it. We were able to, with this amount of line of code, this is the amount of line of code. So this is that we were able to. This is GL. Yeah. So actually, but the results is it. So this is just a repeat. We have to close it. Okay guys, I think yeah, maybe is this, nope, it's actually okay. Let's go and try to draw a triangle. Okay, let's define a triangle from 3 points. Later we can look at doing transformation perspective, but for now let's draw it flat onto the final string. X between 0, -1 and 0, -1.0 and 1.0. X and Y between -1 and 1. Yeah, going downward, because in graphic programming I don't know that why the y-axis doesn't always goes up. It never actually goes up. It's just you that have to scale it in your code. Like you have to tweak it in your code so that you can still be working as if you were doing real math. But under the hood, yes, under the hood is going downward. I have to draw your program on paper first. Here I wanted to define a triangle. So the triangle, I want to put it in the center. So the coordinate is in 3D. OpenGL is a 3D graphic. So 2D, 3D, kind of, I think. Yeah, I think it's 2D. Anyways, let's continue. So the first point, X, 0 point -0.5, Y, 0.5, because 0 is here, so -0 is here, and the Z coordinate is 0. The second point is the minus, yeah, 0.5 -0.50, and X is 0 versus, yes, X is 0, Y is 0.5, and Z is 0. So we will pack all of these points in a big array of floating point number 9 in total. We will start with the top point and process clockwise in order: X, Y, Z, X, Y, Z, X, Y, Z. the other should always be in the same winding direction, clockwise, anti-clockwise. So the clock is going like this, we go like this. So I think we'll start with 0, 0.50, then clockwise 0.5. So yes, we go like it. 0.5 minus 0.5, 0.5 actually. First, yeah. So we define this, and so that we can later determine which size is the front and which size is the back, we can start writing this under the other stuff goes here commands. So actually here we define our points. So the first point is x is 0, the x dy is 0.5, is 0.xyz of the first point. Okay, the second point is like the x is 0.5, the y point, like the first point, the x is 0.5, but the y point is minus 0.5, 0.5, the z is always 0, xyz of the second point, and the third and last point is the x is minus 0.0, minus 0.5, the y is minus 0.5, and it is x and the third point, yeah. Our triangle points. We will copy this chunk of memory into the graphic card in the unit called the vertex buffer object, VBO. To do this, we generate an empty buffer, set it as the current buffer in OpenGL state machine by binding it first, then copy the points in the current buffer. So we create a buffer. Vertex buffer is going to hold our vertex text object, I think VBO, called abbreviated VBO. To do this, we generate an empty buffer, set it to the current buffer. OpenGL state by binding it first. Then copy the point. So we do GL in VBO. GLU int VBO buffer. Wait, what? Like a lot of type. It's just an unsigned int. Unsigned ints are int that cannot be can't take negative values. So GL generate buffers. One buffer by GL generate gen buffers. Yeah. GL. Look at this. GLs. Generate buffer. Buffer V actually is VBO. Gen. Oh. Buffer. Generate. This is it now. OpenGL functions. Yeah, create a window. Create a context. This is it now. Yes, a window. Don't tell me you want glad actually, because I don't like. Yes, then GL buffer read SDI How can we generate buffer? Don't tell me we won't need this, God. I don't want to use it though. Seriously, I don't want to use it. Anyways. Okay, let's see. Open here for that one. But the vertex array but GLF gen of tons. OpenGL loader. Trying to migrate my OpenGL function is tedious. The industry standard is to generate a loader. I've already done it. Is this going to work? I have in part of my ketchup where let me just configure this. No. Oh. Wait. Kernel dev volume stuff. Here's the external. This is glad, so I'm going to copy item recursive. Path is dev volume stuff. Volume external clad into here. Then I'm going to create a new directory called external. I'm going to more recursively declare into this destination external. Wait, move glad to destination external. Get child. Okay, we can see that here we have the glad directory. Yeah, and in this external we are going to add a CMake list here, and we are going to add library glad. Get child, get content, user, kernel dev, organ stuff, external. Okay, this is it, the library. So what we do here, what we are doing is that we are just configuring the glad DLC, the glad library actually. I didn't include that would be glad public glad include. This is the only thing that we are doing here. Then we are going to make a CMake here, and in here what we are going to do is that we are going to load add submodule, add subdirectory external. Then here we go, are going to link to glad, and if we compile this, we come here and like the current context. Yeah, after loading the current context, we want to load the vulgar is glad load GL loader. Glad load glad it hasn't set it up. Okay, processing files. Glad. Okay. What we do is glad load proc. Glad load glad load function SDLJ get processing SDLJ get process address. Glad load glad GL loader. Load. Wait, what? How to use glad with L03 for OpenGL for that one. Okay, this is taking a lot of time, guys. Okay, let's see where it is. Create context. There is no glad load GL loader. Glad glad load form. Arial get process address. So what we do is the glad initialize glad. Okay, let's come back here and see if the GLF gen buffer is taking. God damn. Take a VBU buffer. ALF glad ALF. Oh. Yeah, this is actually the function. Type void. This is it. We define this function. They include buffers, list of buffers. The left side, the numbers of buffers, GL gen buffers. Yeah, this is it. Glad. This is it. So, and this is it. So this is the function that we call. Yeah, calling. Anyways, let's continue. Generate the buffer, one buffer. List of buffers, generate one buffer. We bind it first. An array buffer. So GLF bind buffer the target VBU buffer GLF array buffer the target we bind to GLF array buffer VBU buffer. Now we set the data to the buffer 9 because it's actually 9, but we don't know the size yet. So GLF data buffer data actually it take the target GLF buffer data array buffer now I take this the size of points divided by size of points 0 times size of floats. This is how we get past the point, and the usage is static GLF static draw. Static draw. This the last line tells OpenGL that the buffer is size of 9 floating point and gives the address of the first value. Now, an unusual step. Most 3D meshes will use a collection of one or more vertices buffer object to hold vertex points, texture, coordinates. Coordinates, vertex, and etc. In all the OpenGL implementation, we would have to bind each one and define the memory layout every first 3 times that we do the mesh. To simplify that, we have a thing called the vertex array object, VAO, vertex array object, which remember, oh god, sorry guys. Okay, I think I'm just going to do like this. Okay, sorry guys. Okay, yeah, VBO, which remember all of the vertex buffer that you want to use and the memory layer for each one. We will set up a vertex array object on image. When we want to draw, all we do then is bind the appropriate VBO. The appropriate VAO and draw. Okay, the VAO. So we define also I said that this is an unsigned VAO buffer. Vertex array generate GLGen vertex array VAO buffer. The buffer, oh god, we bind the VBO. So GL bind the vertex array, the vertex bind the vertex array VAO buffer, and then we enable the vertex attribute array. Enable the vertex attribute array to 1. So we disable the vertex attribute array. JLF buffer, JLF bind buffer. We bind the buffer array buffer. Bind the buffer. VBO buffer and GLF vertex attribute pointer. Vertex attribute pointer. GLF vertex attribute pointer. What it takes the index 3, the size 3, the enum, the floating point, the G false. I will just get this working, and the what does this function do? Large vertex buffer. Okay, I'll close everything. Okay. Here we tell OpenGL to generate a new VAO for us. It sets an unsigned integer to identify it with letter. We bind it to bring it to the focus in the state machine. This lets us enable the first attribute 0. We are only using a single vertex buffer, so we know that it will be attribute location 0. Only one location 0, yes. The value pointer function defines the layout of our first vertex buffer. 0 means define the layout for attribute number 0. 3 means that the variable combination type called vec3 made from every 3 floating point. You might try compiling at this point to make sure that there were no mistakes. So let's compile. Yeah, this is it. Okay. Nope. Shader. We need to use a shader program written in OpenGL shader language to define how to draw a shape from the vertex array object. You will see that the attribute pointer from a VAO will match up to our input variable. You will see that the attribute pointer from the VAO will match up to our input variable in the shader. This shader program is made up from a minimum 2 part, a vertex shader which describes where each 3D vertex point should be placed in the display area, and a fragment shader which the color of each pixel size fragment of the mesh surface. Both are written in plain text and look a lot like C program. Loading this from plain text would be nicer. I just wanted to save a bit of web real estate by hard coding them here. So this is our vertex. So this shader program is made of 2 parts. A vertex shader which describes where each 3D vertex pixel should be placed in the screen, and a fragment shader which is the color of each pixel sized fragment of mesh surface. So this is the vertex shader program. Vertex shader program. The version 1.0 call. It's int vec3 vector point void main. Position VP 1. Define the position we describe where each 3D vertex should be placed on the screen. Vertex placed. Our vertex pixels should be placed on the color by our pixel fragment vertex. This is which version of the shadow language to use. Here we use probably present my vertex shadow has one input variable before a vector made of 3 for which matches up our VA attribute pointer. This means that each vertex shader invocation gets 3 9 from our buffer. Therefore, 3 vertex shader run concurrently, each one positioning one of the vertices. The output has a reserved name and expect a 40 float type vec4. You can see that I haven't modified this at all. It's added 1 point to the 4th element. 1 at the end just means don't calculate any perspective. The fragment shader, the color, fragment shader program. Frag color. Yeah, this is a British guy who wrote this. We still haven't told OpenGL that it will be a single triangle. You can guess that for our triangle we will have a lot more fragment shader running than vertices shader for this. Since our triangle will cover more than 3 pixels, this fragment shader has one job: send you the color of each fragment. It therefore has one output, a VD vector representing a color map from red, blue, green, and alpha component. Each component has a value between 1 and 0. Alpha component, so we left it so. Actually, we have to load the strings into OpenGL shaders. OpenGL shaders. Into OpenGL shaders. So, vertex shader program. Here it is. And sign in. Vertex shader program. GL create shader. Here vertex shader. GL create vertex shader. GL shader source. We will load destination. One vertex, the vertex shader no. GL shader source. The shader vertex shader program. The come on string. Well, compile shader point. Do the same thing now for the fragment shader. Fragment vertex shader. Frag. Now this compile the shader must be combined into a single executable GPU shader program. We create an empty program. I lost my connection guys. We create an empty program attached to the shaders, then linked together. Right, to get something up and running. This is what we have to do. Okay, we create a shader program. Shader project, create program, attach shader. Yeah, attach shader program, vertex shader program, attach shader, fragment shader program, program linked, JLS linked program. So we combine. Now we go to the drawing part. We draw in each iteration draws the screen once. A frame of rendering, the loop finishes. A window is closed, then we can act. Another way to close. Actually, GLF pull events. While application is running, the pull events, handle events. While pull events. Then we switch an event type. Case is here. Because I want the exact as the key down. Now if event key is as the escape the okay. Handle drawing. Okay, what Wipe drawing buffer clear. Wipe the drawing buffer clear. Buffer bit def buffer bit. Yeah, clear the buffer bit. Color buffer bit. Yeah, depth buffer bit. Yeah, depth buffer bit. Put the shader program and the VAO in focus in OpenGL state machine. Here use program shader and bind vertex array. Here use program shader. Here bind vertex array VAO buffer and draw point 0 to 3 from the current bound VAO, the current in use shader. Draw rays, here triangle 0 to 3. Here draw rays, the triangle. SDL swap. Swap in the application. Yeah, by that way, manually call the unknown graphic event like keeper. We clear the drawing before drawing, then set the shader program that should be in use for all buffer. We set the VAO, not the VBO, as a geometry input that should be used for all. And we can draw, and we want to draw in triangles mode. One triangle for every 3 points, and draw from point 0, from point number 0 for 3 points. Finally, we swap the buffer we have been drawing to onto the visible area. Done. So let's test it. Let's cross our finger. Actually, it's not loaded. Don't know why. I'm going to debug it. View buffer, shader program, buffer bit, depth, frag color 0.5, main frag color core, VP, this in this configuration. Okay, with what? We create shader shader program, create shader program. Fragment, we set the fragment shader first. We set the fragment shader, the vertex shader, linked program. Create shader, GF fragment shader. This is it here. Fragment shader, copy and pasting. I say, fragment shader. One. Okay. One null vertex shader program. Okay. BAO buffer, vertex array, generate a vertex array, bind vertex array, bind vertex array, enable vertex attribute array. Oh, vertex attribute array. Actually, here it is. Find buffer, review buffer, vertex attribute pointer, float false, 0, divided by the first element, array buffer, static draw. Here we can see, it's quite like it's the same. This is on Linux, this is on Windows. Doesn't scale. Anyway guys, this has been a real beautiful tutorial, and I hope to see you guys later. I really do hope. So guys, don't forget to leave a comments below, like, subscribe and share. Ask questions, give recommendation, so that I can so that I can grow, I can be a better software engineer. So see you guys. Ciao.